3.7, solve the system of linear inequalities by graphing. In this problem, we are being asked to solve the system of linear inequalities graphically. Here's our system, and so we'll need to deal with each of those lines. The easiest one, I'll do it first, is y is less than or just strictly less than. In order to do this graph, I will pretend it's equal and graph the line. I'll make that dotted when I do the graph. Let's make a note. It's dotted because it was not equal to, it was strictly less than. Okay, let's make a table and get a few points for this. It goes through the point 0, put an x in, 0 for x, and y equals 1. Let's put a 2 in. 2 times 2 is 4 and 1 is 5. Let's put a -1 in. -1 times 2 is -2 plus 1 is -1. Okay, so we have 3 points. That should give us that line. We might as well go ahead and draw that while we're at it. Remember to draw it as a dotted line because the initial inequality did not equal that. So it goes through the point -1, -1, 0, 1, and 2, 5. Okay. Get my straight edge here and draw this dotted. Okay, let's take the other line now. We'll need to work with it a bit. I'm doing the equal to part to graph the line. Oops, that's a 7. And I'll begin by trying to solve for x here. Subtract the 3x to the other side. And we get -3x over here. And now I do divide the 4 off. So I have -3 divided by 4. And -7 divided by 4. And we'll need to be careful what we put into this. Let's make a table. I've worked this out ahead. -1 works out to be a nice value because that gives us a +3/4 and a -7/4, which is a -4/4, which is -1. And a 3 works out nicely too because that gives us 3/4 times 3 is -9/4 minus 7/4, which is -16/4, which is -4. So those are not the greatest points, but they'll work to get this line. So let's put those on the graph. -1, -1, that's a great point because notice that it was on this other line also. -1, -1 was on both, so we have found the intersection point with that. And we have 3, -4. All right, and this is a solid line because initially we had it equal to this. It includes the line. All right, now we need to go back and shade. Initially with this first line, which I did in pink, I was supposed to shade where the y values are less than that. So when we look at this line, the y values would be less on this side because that's lower, and then we will test a point to verify that. I'm going to shade over here lightly with the pink, and let's test the point 0, 0, which is in here, and we want to test it back in the original inequality. We're testing the point 0, 0, so I put 0 in for y, and I put 0 in for x. And I get 0 is less than 1, and that's true. That point does work, and this is the solution area. I verified that. Now let's take this other line, and it asks us, I think I'll graph this in green. Initially we were supposed to graph where, well, the y is on the greater than side. So we want y greater than this. And so y's will be greater than this black line that's graphed when it's above. The y's, larger y's are above that. So that would be this region over here. And again, it looks like that pin's about dead. We want to test a point, and notice that 0, 0 is also in this region that I just shaded. So I'm going to test 0, 0. Test 0, 0 in the original equation, inequality that is. Put a 0 in for x and a 0 in for y, so that goes to 0. So is 0 larger than a negative 7 or equal to it? Yes, it is, and so that is the region. Now, to solve this, notice we're not just looking for the intersection point of the lines, but we're wanting to know where it satisfies these inequalities, where it's either the line or the shaded region. So we want this region over here that's shaded both green and pink, and we're going to go through and shade that very darkly so that it will be clear to everyone that this is the region that satisfies both of those inequalities. And we want to go right there to that where V that's formed by the two lines. Right up to the lines all the way along the line. So the solution is this graph, the shaded region, this line, and that's the other boundary.